Hi and welcome to this video. Today we're going to look at how bond order and resonance affect bond strength. In other videos we're going to look at other factors such as hybridization, so be sure to check those out. So let's start with this problem here. We're going to circle the strongest bond in escitalopram. So when you're thinking about bond strength, one of the easiest things to consider first is the bond order. So you probably know that a triple bond is stronger than a double bond, which is stronger than a single bond. So if we apply that to this problem here, the strongest possible bond would be a triple bond, and I do see one right here. And I'm only seeing one, so that means that it probably is the strongest bond. So that's pretty straightforward, but now let's look at how resonance affects the bond order. So in this problem here, we're comparing two bonds which both appear to be double bonds at first glance, but in the first case, the double bond is involved in resonance, whereas in the second case, it is not. So let's look at the resonance structures of benzene to see how resonance affects the bond strengths. So half the time the bond looks like a double bond, and half the time it looks like a single bond. So which one is it? Well, actually it's neither. If you think about the resonance hybrid of benzene, the bond order is 1.5 or 1.5. So it is in between the single bond and the double bond. So this shows that resonance makes a double bond weaker by causing it to have more single bond character, which is what we're seeing here in this resonance structure. Now if we look at the isolated double bond in cyclohexene, the bond order is 2. And we know that a larger bond order means a stronger bond. So the strongest carbon-carbon bond belongs to the cyclohexene. So the takeaway here is that resonance makes a double bond weaker. So let's look at another problem. Here we have lutein, a fairly large molecule that has lots of different types of bonds. But let's first look at the bond order. So I've got some double bonds and I've got some single bonds. So I would expect the strongest bond to be one of the double bonds. Then I can think about conjugation or resonance. And all of these double bonds are conjugated, whereas this one is not. So based on what we said previously, where resonance weakens the double bond, the strongest bond should be this one here. And finally, here's one more problem that I will leave for you to think about. Let me know in the comments if you think the answer is molecule A or molecule B. And if you found this video helpful, please like and subscribe, and also be sure to watch my other videos on factors that affect bond strength.